So I chose to do my presentation on the principle facilitating meaningful mathematical discourse, and I wanted to start with a quote from the Principles to Actions text. Students who learn to articulate and justify their own mathematical ideas, reason through their own and others' mathematical explanations, and provide a rationale for their answers, develop a deep understanding that is critical to their future success in mathematics and related fields. So through this discourse that this quote was talking about, students can be authors of their own ideas and also teachers of their classmates and their peers, and hopefully even teachers, and they can learn from the perspectives of others. And in doing this, I think it's really important to set up a classroom culture where that discourse is both inquisitive and safe. I know for myself, I have always struggled with math and felt unsuccessful in a lot of math classes, and part of that was the culture that surrounded those math classes, and the kind of competitive culture and that idea of like a strong right and wrong answer. And although there are really right and wrong answers in math, the students who are able to work through that are able to have something to add and to teach as well. So I think it's really important to set up that culture where students don't just shut down and become disengaged, and they're really supported. And so some ideas I wanted to share. So giving equal attention to right and wrong answers, because wrong answers are showing that we are taking risks. And that's really important in math, that we're not just playing it safe and using the strategies that we know and doing math that we already know, but we're working hard and taking those risks. Calling on a variety of students instead of just the students that you know already know the answer, and students that are always those ones their hands raised. And highlighting what students are doing well, even the students who are struggling, or especially the students who are struggling, even those ones are doing something right or doing something well, or can be built up. And thanking students for sharing. I think that this is important in all sharing across academia, that it's always important to thank students for sharing and show that you honor what they have to say and value their work. So I wanted to do an activity. So first, if you are watching this, you can take out a piece of paper and a pencil so I can demonstrate a mathematical discourse. Okay, so I'm going to pretend that you are a third grade student, to draw an array and write a number sentence to match the following problem. The custodian is setting up for a concert. There are 5 rows with 4 students in each row. So go ahead and draw an array and write a number sentence to match this problem. I'll give you a moment. So before I started this activity, I've already anticipated student responses. And this will change with every group of students that I have. So some examples, and I have done similar problems with the students I have in my current 3rd grade placement. Students might draw the array correctly and also write 5 times 4 equals 20, or they might write 5 plus 5 plus 5 plus 5 equals 20. Some students may add a row or a column, or draw too few rows or columns. Some students may also just write 5 times 4 and not an answer or an array, or they might write 20 without drawing an array or the number sentence. So I will also be monitoring student work while they are doing this problem on their slates or on paper. I would be walking around and looking at the work that students are doing and making a mental list of who I'll be calling on. I'll then be selecting particular students to present, and that's happening while I'm monitoring student work that's being done. So I gave some a example. So student A has drawn the array correctly, but did not write a correct number sentence. Student B has written a correct number sentence, 5 times 4 equals 20, but did not write the array. And student C has written the number sentence and the array and clearly understands the concept. So to sequence these student responses, I would have student A go first, as they have an important part of the number problem, but they left some for another student to add. Student B will be second, and they'll fill in the blanks that student A made. And student C will then make the connection between the array and the number sentence, because they understand that those two are connected and how that works. And to connect those responses, so I would have 3 students writing on the board at 3 different times. When everyone's sitting down, I would ask, how was student A's response similar or different to student B or C? And allow that open response question to be answered by any student who wanted to. And then I would comment on what I noticed about student thinking and offer compliments. In order to extend this discussion, I would give another problem, because I know the students in my current third grade placement, they know their 2s, 5s, and 10s multiplication facts, and they're learning about helper facts. So they mostly should know 5 times 4 equals 20. That's a fact that most of them are fluent in, but 5 times 6 they would not necessarily, 4 times 6 they would not necessarily know. So this is my extension. There are now 4 more students who showed up to the concert at the last minute. Write a new array for this situation. I will also tell them, think about how 5 times 4 can be a helper fact. Now, when I give this, I'm basically doing the same process over again of anticipating the student responses, looking and monitoring student work, and then as I'm monitoring student work, I'm thinking about what sequence I'm going to be having them respond in, and then what connections I can make. Basically, the objective here is I want them to figure out that 5 times 4 is a helper fact, to figure out 6 times 4, so they can just add one group of 4. That's kind of what we're getting to, but there will be I'll be asking questions in order to elicit the students to get to that point eventually. So in summary, things are not always going to go as planned. The way I just explained it sounds like, the kind of the ideal situation where students are kind of teaching each other and themselves how to solve this particular problem. But you always want to have a plan for questions that you can ask to guide the discussion, because it is facilitating a discussion, and we need to kind of have lots of potential questions in our back pocket based on how students respond. Also, facilitating a discussion is like guiding students to teach each other, but really you're orchestrating the whole thing and allowing students to think that they are actually teaching themselves and each other. But by having them articulate those ideas and out loud and to their classmates, it is empowering them to be a part of their own education, and also to see that their classmates can be teachers as well.